Hi guys, welcome to my hackathon project, the game of skate with Slido. As many of you probably know, I love skating. I've been skating for probably 20 years now, and that's why I choose this topic. So let me briefly explain what is the game of skate. It is a well-known game between skaters all around the world. You can imagine skater A is showing a trick, and skater B is trying to repeat the trick. If he failed, he's getting a letter. If he's got 5 letters, he's losing the game. So the goal is basically repeat as many tricks as possible. So what is my idea? My idea is to show the trick in the quiz and then repeat the trick on the skate and vote to the quiz this way. So how to do it? Let's split the problem into a few smaller steps. First will be to record the trick, then recognize it, and of course vote back to the quiz in time. For the recording part, I created some small tool or utility to record the raw data from gyroscope, and I simplified the problem, so I was just recording like 10 seconds and store it into the CSV file. My first attempt was this device on the right. Android app sent a signal to the device to start recording. Then the device was sending raw data back to Android for 10 seconds, and then the logic should be continuing in the Android. But I face several problems, like I had to increase the baud rate of the Bluetooth, and there was a issue with the distance, so I had to carry the phone all the time. And after a few attempts, I lost the data, and the gyroscope was not responding. So I had to choose a different way how to record the data. So I choose a smartphone. I created these holders and attached phone to the board. It was a little bit bigger and heavier, but it was still doable, and this way I was able to record some data. So let's take a look at the data. The gyroscope library is allowing us to choose from several types of the data, like a row, different in the movement and rotation, and probably several more. For this project, I choose rotation. As you can see the graph right over here, the representation is not very helpful because when it's like reaching like minus 180, then it's switching to the plus side of the graph. So in the first iteration, I had to clean or like normalize the graph so I can see the continuous values. So right here, we can see that I was putting down the board, I was rolling, then there is a small ollie, and the board changed the direction for 180. So this is exactly what I was looking for. There was one more issue. I also had to like do the y-axis correction because the graphs were not starting at the same value, so I just have to move the y-axis. And this is a example of my data set. These are a few showbits here and a few kick clips over here. So the recognition of the trick. Firstly, I was thinking that I'm gonna use the machine learning, but before that, I just tried something very simpler, the dynamic time wrapping. It's a commonly used algorithm in many industries, and it's basically what it does. It just compares two graphs, and it said how far is one graph from the other one. So the bigger value, then the graph is so different. The smaller value, the graph is so closer. So after cross testing my data, I came to conclusion that the threshold what I was looking for is like 400 to recognize the tricks. Quick summary before the demo. The quiz is showing a trick name. The skate is starting to record. I'm doing the trick. After 10 second recognition starting, and then sending data back to the API. So let's take a look at the demo. Hi guys, welcome to the hackathon demo part. So let's get started.
We got a quiz right here, and we're gonna join one participant. Okay, and then we're gonna start reading the quiz. Okay, now let's go to the first question. Do a pop show it. Okay, the show it was recognized. You can see the value. Okay, so let's do one more. The kickflip. Let's take a look at the result. The flip was recognized and the threshold is below 400. Yeah. That's it. Thanks.